Good afternoon. Hope everybody had a good lunch. We're going to go ahead and get started here. You know, last June I was in Beijing with Oleg from Postgres Pro, one of the organizers of the conference, if you don't know. And he says to me, GD, will you submit some content to PGConfRussiA? I said, sure, I'll give a couple of talks and you let me know what you want. So I submitted two trainings and a talk. I didn't know he was going to have all three of them. So this is a long day. Not complaining, just a little bit of a surprise. Don't take this personally, but who was in the training that I gave before lunch? Whoa. Okay, cool. Thank you. All right, so you know who I am, so I'm not going to go through all that again. The one thing I will ask is that all of you get your United States visas and come to our conference. It's March 18th through 22nd in New York City. 5 days of pure Postgres fun. We're going to have the first 2 days are training, as well as specialty vendor summits. So we got an Amazon summit, we got a Google summit, and then we have a Pivotal Greenplum summit. Any of you doing big data stuff will love the Greenplum stuff. It's, if you don't know, it's a open source fork of Postgres that can deal with things like petabyte level of data. And then Wednesday through Friday, we'll have over 100 breakout sessions, cocktail party. At the cocktail party, we have games, and I don't mean like bar games, I mean like we have foosball, air hockey, Dance Dance Revolution, those types of things. It's a lot of fun. It's a really busy, long week. But we're the largest conference in the world for Postgres, and we're targeting 800 people. If just the people in this room showed up, plus the people we already know are coming, we'd hit 1,000. So please come if you feel, you know, the need or the desire to see New York. It's a great place to go. This training is practical Postgres replication. I don't do theory. I leave theory to engineers and people who spend more time in front of the monitor. I'm more about how can I help you use Postgres in production. I think my battery just died. Nope, there it is. All right, so I'm not going to go through the table of contents here. This particular training may not go the full 3 hours. It'll depend on various things. The training itself only has, we only discuss, the first part of the training, we only discuss binary replication. The second part of the training is logical replication. If we don't get to that, it's the exact same slides of the presentation I'm giving tomorrow. So if we don't get to logical replication, because we didn't finish the performance talk, in fact, I was surprised. That training is normally a solid 3 hours in and out, and we probably wouldn't have been done at 5. So if we don't get to it with this, that's okay. You guys can definitely come to the presentation tomorrow and we can talk about logical replication as well. Per the other training, this training succeeds based on your participation. Please ask questions. That's what it's for. I want to help. I just want you guys to succeed. Oh, there you are. What was that? I'm sorry, I can't hear you. Barcode. Oh, yeah, the barcode, we will get it. They're not here yet, but we'll definitely get you a barcode to download it. Okay. Here. Well, that's about the 300th time you've taken my picture, so I got to make it a little interesting. He will have the barcode. They're already asking for the barcode for the curriculum. All right, so introduction. This training is designed to provide an attendee with practical curriculum for Postgres operations in regards to replication. We will discuss types of replication available, provisioning, custom configurations, and administration. Expectations. This is a comprehensive but introductory training. If we were to cover everything related to replication, this would easily be a 3-day training, not a 3-hour training. We are trying to get administration up and running with basic but reliable knowledge to enable, administrators up and running with basic but reliable knowledge to enable them to use binary replication. We will also attempt to address logical replication. However, if we are unable to reach logical replication, I'm giving the same logical replication content as a presentation tomorrow. Versions. The curriculum currently discusses version 10 of Postgres. Let's talk about types of replication. Is that too small? I heard yes, so let's see what I can do. Is that better? Okay. Postgres has 2 native types of replication. The first and most robust is binary replication. The second and relatively new, not even relatively, it is new, is logical replication. Each type has its pros and cons as well as different administration requirements in order to deploy it into production. We will also briefly discuss previous replication options. What is not covered? We will not be discussing the following technologies in any comprehensive form. Point-in-time recovery, because that's not replication. That's backup and restore. Slowney, because you got to be nuts if you're running Slowney. Has anybody here ever run Slowney? You know what I'm talking about. Don't get me wrong. For the time that it came out, Slowney was a good piece of software. But it suffered from over-engineering. And the best way I can describe it is a bunch of engineers got in a room. They were told to paint the wall black, and they asked which shade of black. Way too many features, way too extensible. You know, you want to do that real quick? Okay. Hold on a second, folks. Okay. We will also not be talking about Picardo. And we will also not be discussing multi-master. Now, don't get me wrong. If you want to ask questions about multi-master or Picardo or something like that, I can speak to a high level of them, and I can also help point you in the right direction to get the solution you need. When I say we won't be discussing something, I mean I am not going to teach on it. So please feel free to ask if you have the question. But if you say to me, how do I install BDR, I'm going to say call second quadrant. But if you say to me, what are solutions for XYZ, happy to try and help you find what you need. Why no discussion on multi-master? Multi-master is a difficult problem, and there's currently no native multi-master replication options for Postgres. Further, by far, the number of people who think they need multi-master do not understand the problem they are trying to solve. The number one question, or I should say problem people think they're solving with multi-master is performance. I hear it all the time. I want more masters so I can go faster. Multi-master does not, will not, and will never increase performance. That's not what it's about. It's about reliability across region. PITR, it's an acronym for point-in-time recovery. The technology uses log shipping, the wall logs, to allow a replica or slave to be a cold, warm, or hot standby. If you are using the cold version, you are able to restore to a specific point in time or transaction. Very, very useful. Has nothing to do with replication itself unless you have to ship logs for your replication. It's more used for disaster recovery. In case you drop a table, modify a bunch of data accidentally, you can restore to a point in time to get that data back. Slowney was the first production-grade logical replication option for Postgres. It is open source, trigger-based, and exceedingly flexible. However, due to that flexibility, it is also complex to manage and suffers from certain performance issues. The most obvious one is that unlike binary replication, with Slowney, the larger the number of replicas that you have, the slower everything goes. Bucardo is similar to Sloaney, except that it's multi-master. It is a multi-master replication engine. It is open source. However, as it is trigger-based, it suffers from performance issues, and as it is multi-master, it can be difficult to administer. One of the biggest problems with multi-master is conflict resolution. How do you know which row from which master is the valid row? There are other technologies available as application-level replication, which can be implemented using software such as Jakarta, Continuant, and various other proxy software. ProtoDB is an example of that. All right, so let's talk about some initial replication questions. There are 3 questions that we must answer before we can determine the best kind of replication for your needs. Do I need synchronous or asynchronous replication? Do I need binary, logical, or both? Do I want to stream or ship? Synchronous replication. Synchronous replication implies that all commits must be available on the replicas before the commit will process on the primary. We do support full synchronous commit as well as quorum-based synchronous commit. For those who were in here before, they already know what this is, but quorum-based allows you to have a pool of synchronous replicas that will address commits coming in, and when those commits come in, the master can proceed, even if there are other synchronous replicas that are outside of the quorum. If you don't do this, all replicas that are in the synchronous list must process the commits before the primary or the master will take over. Or continue, I should say. Pros and cons of synchronous replication. The pros of synchronous replication are that you are guaranteed that the primary and the replica or replicas are in the exact same state at any point of failure. There is no arguing that that is valid and helpful. It is nice to know that if the master dies, your slave is exactly where the master was at the last commit. That is data integrity at its finest. The cons of synchronous replication is that you will suffer a performance penalty and potentially an outage in the event that a replica that is within the synchronous configuration is suddenly unavailable. That is a huge downside to synchronous replication. If you have a replica that decides to disconnect, the network goes down, the internet goes down, it doesn't matter. The switch port goes bad. Somebody kicks it and turns it off. It doesn't matter. Your primary will stop. It no longer works. Now, to be fair, all you have to do is remove the failed slave from the synchronous standby names list and reload. It's possible to do that. But I take issue in the fact that I have synchronous replication, so I will not have an outage. And the fact that synchronous replication can cause an outage, to me, is a con, not a pro. It is not recommended to use synchronous replication unless you have a networking interconnect that is able to move faster than the I/O that you are utilizing on the primary. That's big. Think about it. Even today, most networks, private networks, are only on gigabit. My laptop can move data faster than that because I have an SSD. So if I have a master and I have a secondary and I have SSDs, I am actually not getting the full benefit of my SSDs because the networking interconnect for synchronous replication is slower than the SSD itself. So at a minimum, realistically, if you're running synchronous replication, you need a 10 gigabit interconnect between the primaries and the secondaries. Okay? We will discuss synchronous replication more in depth in further sections. Asynchronous replication. Asynchronous replication is the most widely deployed protocol for replication. It also implies that data will commit on the primary before the replicas, and the replicas are allowed to lag behind the primary. The asynchronous nature makes this choice for most widely used for geographically dispersed installations. And it's not just that. I mean, even if you have a local primary and secondary, I would recommend async unless you have a very specific problem you are trying to solve that can only be solved by synchronous replication. Otherwise, just use asynchronous. And as you can see with the graphic, it's pretty simple. I mean, you can go across continent. I'm not sure that I would go from, say, Seattle to Moscow. I might think about using cascading replication for something like that, just from due to the latency. But certainly cross-continent or cross-country. When using asynchronous replication, there's generally no performance decrease for replication. That's true. If your network interconnect is fast enough, it is possible to achieve what some call semi-synchronous replication. And there's a lot of different definitions for semi-synchronous. My definition of semi-synchronous is that it is asynchronous replication that is moving fast enough that it might as well just be synchronous. You're not paying the performance penalty or the outage penalty of synchronous replication, but since your interconnect is fast enough, your primary is fast enough, your secondaries are fast enough, it's essentially, or in practice, synchronous. Okay. However, it is possible that in the event of a primary outage, your replica may be in a different state than the master and data loss is possible. That's absolutely true. It is asynchronous. You have no guarantees. The way you solve that problem without running synchronous replication is that you use monitoring. Monitoring will tell you, my replication is 5 seconds behind. My replication is 5 minutes behind. Why? How do we fix that? Those types of things. Binary, logical, or both. Each replication option has different operational requirements. Binary replication can only replicate an entire cluster, whereas logical replication is able to replicate partially. It is also possible to integrate logical replication into a binary configuration as well. Now, what do I mean by that? With binary replication, which is built into all versions of Postgres, is a byte-by-byte identical replication, meaning that if both your primary and your replica are stopped and in the same state, the page files, the files underneath that contain your data, on the primary and the replicas will match. And when I say match, I'm not talking about just the data inside. I mean, if you checksum the same file on the primary as well as on the secondary, and they're in the same state, that checksum is going to match. They're completely identical at the binary level. Further, binary replication is only able to replicate an entire Postgres cluster. There is no partial replication available using this option. Seems like an obvious statement, but it isn't. What it means is you can have an installation with 50 databases. Those 50 databases are used by 50 different applications. With binary replication, if you replicate, you will have those 50 databases replicated wherever you're replicating, no matter what. There is no, well, I take that back. There is one option for binary replication. Cybertech out of Austria puts it out. I can't remember what it's called, but what they actually do is read and parse the wall logs as they're being generated and allow you to binary replicate through a filter. I've never used it. Sounds kind of hacky. But, you know, sometimes there's a big red button you need to push to see if it'll work. All right, here's a sample binary replication architecture. Postgres supports a single master to many slave architecture. The architecture also extends to cascading slaves. For example, in this example, we have a master, we have a slave, and then the slave has slaves. It's a really good configuration for in a situation where the master and the slave are fast. The interconnect between them is fast. But slave 2 and 3, the master can't get to them for whatever reason. Maybe it's a firewall, or maybe the connection's too slow, or whatever. And the slave actually has a fast interconnect to slave 2 or 3. It's also good for DR, disaster recovery. It's nice to be in a situation where in one data center, you have a master and a slave, and then in another data center, who knows where, you have another slave, but it's connected to the first slave because you don't want to slow down the master. You don't want the master to have to process those extra replication requests. Now, it's relatively lightweight, but it's still there. Logical replication. Logical replication is the process of replicating results of data modification. It has a particular benefit in that it can be used in conjunction with binary replication. It also has the benefit of being able to replicate partial data sets as well as cross-replicate data. It can also be used to replicate to alternate technologies such as Kafka or even MySQL. Don't do this. Use Postgres. I'm going to say that one more time. Don't do this. Use Postgres. But it's true. You can, in fact, in the logical replication talk, I have a link to the logical decoder that allows you to replicate from Postgres to MySQL. I have no idea why anyone would do that, but, you know, to each their own. Here's an example logical replication architecture. As you can see from the diagram, logical replication is exceedingly flexible in how it can interact with your users, as well as your binary replication configuration. So let's take a look at this. So if we look at the left yellow box, we've got a human resources app, plus full subscriber to sales DB. And I won't get too much into what that is because we do talk about it later. But unlike binary replication, where you basically have a master and a slave, or if you're politically correct, a primary and a secondary. What you have with logical replication is publishers and subscribers, which have publications and subscriptions. Okay? So what we have here is a human resources app with a full subscriber to the sales DB. The sales DB is up top here. And that is our public-facing sales DB, so think shopping cart or Salesforce CRM or something like that, right? So publicly, we have a read-write sales DB that's doing everything that it does, and we are publishing that entire read-write sales DB to the full subscriber, which is the Human Resources app plus full subscriber to sales DB, HRDB, Human Resources DB, which is then binary replicating to a logical replication hot standby. The read-write sales DB also, for disaster recovery, is binary replicating off to another data center. The reason we would do this is you never let salespeople near employee information. They will try to sell your own employees. So you want that information separate. HR is, you know, it's private information. It's government identification numbers, birth dates, things like that. So you're able to segregate the data out that we are replicating. All right, let's get into configuring binary replication. These are our binary replication configuration options. The two files you will need to edit for Postgres replication are the PostgreSQL.conf and the PGHBA.conf. We are assuming that your primary and replicas or secondaries are able to communicate with each other over the network, including any firewall configuration. So for example purposes, what we're assuming is that you're on an open network between your two machines. I'm not going to get into how to configure IP tables or SSH keys or anything like that. So the first thing we need to change is our listen addresses. This is the IP address you wish to bind Postgres to. By default, Postgres will bind to localhost, which will not work in a binary replication environment. You must use an IP address that's available to the replica. For example, all, the second one is obviously broken, or the third one where we're binding to localhost plus an external IP of 192.168.1.5. So again, in order for binary replication to work, the secondary must be able to connect over an external interface to Postgres. So it can't be just local host. It must be on the external interface. Max worker processes. It sets the maximum number of background processes the system can support. This parameter can only be set at server start. The default is 8. When running a standby server, you must set this parameter to the same or higher value than on the master server. Otherwise, queries will not be allowed in the standby server, meaning that if it's not 8 and 8 between the primary and the secondary, your hot standby won't work. It'll replicate, but you won't be able to run queries on the hot standby, so you can't load balance or anything like that. When configuring this parameter, keep in mind the relationship, and this is extensive, between not only max worker processes, but also max logical replication workers for logical replication, max parallel workers, which we discussed in the other training. Parallel workers are for parallel query. And if you want parallel query to work, you got to have enough max worker processes, but you also have to take into account that max worker processes is affected by replication. Okay? As well as max parallel workers per gather, as they are all limited by max worker processes. An effort to determine the best value for this setting is difficult. A good rule of thumb is to take each of the above parameters, add them together, and multiply that by 2. Now, that may sound arbitrary because it is. It's completely arbitrary. But it's the only way that I could think of to say, okay, my bases are completely covered for every setting that I have that is limited by this one top setting, and I have enough room in case something else happens, like I need to run more backups, or I need to add a replica, or I want to increase my max parallel workers, or whatever. Wall level. This sets the amount of information stored within the wall for particular features, including logical and binary replication. Unless you are running a minimal system without any replication, the recommendation is to configure this setting to logical. And I agree with that. There's no reason not to have it logical unless you are under significant I/O strain. Because yes, the wall will take up more information if it's set to logical, but on the other hand, if it's set to logical, anything that you want to do that Postgres can do via the logical decoding is there. Whether it be hot standby, whether it be decoding streams to send to Kafka, whatever, it's available to you. Archive mode. This setting determines if you want to use log shipping and or point-in-time recovery. We recommend that you set this to on at all times, as it's not a performance hit and enables the use of log shipping at any point in the future without an outage. So there are 2 points to this. One is point-in-time recovery, which we're not going to talk about, but that the setting requires a Postgres restart to change, but it doesn't do anything if it's on, as long as archive command is correctly set. That's the key. So you can have archive mode on, and if you have archive command set to anything that returns true, all right? So this is the setting that is most appropriate for modification in relation to archive mode. It only requires a reload, no outage to change, and can be set to bin true or equivalent when not in use. It can also be used for hot standby. If you are in an environment where you can ship logs from a primary, but you cannot connect to the primary from a secondary. If you are able to connect to the primary directly from the secondary, the use of replication slots is preferred. That's true. So what I'm saying here is that I've got archive mode on because at some point in the future, I might want to do point-in-time recovery. I don't want to affect my replication. But if I don't have archive command correctly set, wall logs will build up forever until you run out of disk space. Because by default, what Postgres says is, if I get a success return, I will go ahead and remove the wall log. If I do not get a success return, I will keep that wall log until I get a success return. So every time you rotate a log, and under a busy system, it can happen very quickly, you are using more and more and more hard disk space. okay? The other advantage to using archiving is in the event that my secondary, let's go back to this set here. So let's look at this diagram again. Let's assume for a moment that the arrow on the, or that the slave, that arrow is actually backwards. So the slave with this arrow, the first slave, should actually, the arrow should be pointed at the master. In normal replication, it is the slaves or the replicas that connect to the master to receive everything. But as we all know, with replication or any network environment, quite often you can go out, but you can't come back in, right? The firewall lets anybody go out and do whatever they want, but no one's coming back in through the firewall. So with archive command, what we can do is use the same facilities for point-in-time recovery so that that master, instead of having to open a hole in the firewall, will actually ship the logs to the secondary for restore. And you can use that with hot standby. Now, the downside, of course, is you're always going to be at least one wall log behind. Always. So you can't use it for synchronous. It will always be clearly an asynchronous situation. But it does allow you to get around certain... Ooh. I didn't know we were going for a romantic vibe. Okay, now I'm all... My entire environment's changed. So anyway, so the point is that you can get around certain firewall limitations. And you can also do things, and this is a very common thing now. I personally don't understand... Well, let me rephrase. I understand why. It's just not something I would do. It is very common to ship wall logs, archive logs, to S3 and use S3 to store all your logs in case of point-in-time recovery. We're not going to go into that at all. Max wall senders. This parameter is used to determine how many wall processes are created for sending a wall stream to clients. You are going to want to increase this as it is also used for binary-based backups such as PG-based backup and PG backrest. It is also used for streaming replication, so make sure you have an appropriate number available at all times. A good starting point is to set it to a setting equal to max background processes. It's a good starting point, but I don't think it's enough, especially when we start talking about I've got 3 replicas, I've got something doing differential backups or incremental backups, but then I also have my nightly backup, or maybe I have a development team that grabs a copy of production using PG-based backup every hour on the hour to do testing against or something like that, or maybe multiple teams. So when you're thinking about this, more is better. You don't want to overdo it because it does take up resources, but you want to make sure you have enough available. Wall keep segments. This is a historical setting for allowing secondaries to catch up from the primary in the event of an outage or disconnection. Do not use this parameter. Instead, use replication slots or archiving instead. That's absolutely true. If you can't use replication slots, use archiving. Always. Because archiving, you can keep the logs as long as you absolutely must or want, and you can have a data retention period. Wall keep segments was a good-spirited, bad implementation setting because at no point do you necessarily know what kind of churn you're going to get in your wall. So you could end up in a situation where you think, let's say 1,000, right? We have 1,000 wall keep segments, which is 1.6 gig worth of wall. Well, what happens if you have an extended outage for whatever reason? It could be an upgrade, not upgrade to the database, but the upgrade to your software. It could be an extended outage because of natural disaster or whatever. Now, a lot of people think, well, that's no big deal. I'll just take a new base backup. Well, guess what? What if you have a 5 terabyte database? You've just extended your outage because you're going to overrun your wall keep segments, which means you're going to have to take a brand new base backup of a 5 terabyte database. And I don't care what kind of interconnect you have, that takes time. And it's not a short amount of time. Replication slots. Replication slots are an option on the primary. You create one replication slot per secondary you are going to use. The use of replication slots can also pertain to logical replication and backups. The purpose is to keep track of changes in the event of disconnection. Consider something like batch replication or outage on a secondary. It's also very useful if you have a situation where, let's say you have a secondary in Hong Kong, and the bandwidth between Hong Kong and Berlin isn't that great. So instead of tying up all the bandwidth during the business hours, we just disconnect. We're still able to report off of the Hong Kong database because it's a hot standby. It's just behind by 12 hours. And then at 12 hours, it automatically fires back up, reconnects to the primary, and because we're using replication slots and everyone's asleep or not working, we're able to sync back up and get the data, the secondary in Hong Kong, back up to date. Max replication slots. This parameter is used for backups, binary replication, and logical replication. We'll talk about logical replication later. You need this setting to be at least number of secondaries plus 5 for backups. I can't stress that enough. One of the most obnoxious problems is when you think you have enough and then you don't, and you have to take an outage. No one wants to take an outage because they need to add the amount of available ability to add replication slots, right? You don't want to have it set to 5 and then all of a sudden you need 10. And it's very easy for someone to say, oh, I'll never need more than 5. I guarantee you if you say I never need more than 5, you will need more than 5. It has to be something bigger, right? It's got to be, I'll never need more than 20, right? It doesn't hurt you to have the ability to do more, and then you're not limited when you do need to do more. All right, create a replication slot. This is done by executing the function via PSQL or any other client that you have. PG create physical replication slot. Slot name, the name immediately reserved, which is a Boolean, and temporary Boolean. Creates a new physical replication slot named slot name. The optional second parameter, when true, specifies that the LSN for this replication slot be reserved immediately. Otherwise, the LSN is reserved on first connection from a streaming replication client. Streaming changes from a physical slot is only possible with the streaming replication protocol. The optional third parameter, temporary, when set to true, specifies that the slot should not be permanently stored to disk and is only meant for use by the current session. Temporary slots are also released upon any error. So all that, acronyms, LSN, all that stuff. Here's what we're really talking about. The slot name's obvious. We can name it my backup, my replica, replica 2, whatever. It's whatever is valid to your particular configuration. But it's the second one that's important. And it's a very common mistake that people make. If you create a replication slot and you set the second value to false, or you do not use the second and third value, and then you take a base backup, your base backup will likely be invalid by the time you're done. Because the replication slot will not record the wall logs until you connect to it for the first time. It's also something that's easy to forget. I just, 3 months ago was working on a client. I was trying to update their staging server, And I ran a base backup 3 times, all connecting to the replication slot, and it wouldn't come up. And for the life of me, you all have these moments where you feel really stupid when you remember what the solution was. But I was beating my head against the wall, and so I did what every good person does, and I asked one of my employees, what did I do wrong? And he's like, dude, you didn't set it to true. So I went back and read the docs, and sure enough, I just forgot this true statement. And what true means is the moment you create the slot, start recording. That's basically what it means. In practice, start recording the moment you execute, and then you start your base backup so that when you connect, the base backup can catch up. Drop a replication slot, simple enough to do. PG drop replication slot and the slot name. Doesn't take any other parameters beyond that. Drops the physical or logical replication slot named slot name. Same as the replication protocol command drop replication slot. For logical slots, this must be called when connected to the same database the slot was created on. Now, we're not going to get deep into this until later, but the reason for that is that we are not replicating the whole cluster in logical replication. You are replicating a publication and a subscription, which could be in any database. And since databases are isolated from each other, it would actually be possible to have 2 different slots name the same thing in different databases if they're logical slots, not physical slots. We want to view our replication slots. It's simple enough to do. To view what replication slot you currently have in their status, a simple query to the system table, PG replication slots will suffice. As you can see, select star from PG replication slot. There's my slot name, subscriber 0. Plugin is if you're using some kind of logical decoding plugin, it'll tell you what it is. The slot type, it's a physical one, not a logical one. And the data ID and database aren't really relevant in this context. And then whether or not the slot is active. There's a couple of other things in there, but this is just an example. Okay, this is a whole mess of words here. Synchronous standby names. We've talked about this a little bit already. Specifies a list of standby servers that can support synchronous replication. There will be 1 or more active synchronous standbys. Transactions waiting for commit will be allowed to proceed after these standby servers confirm receipt of their data. This goes back to what we were talking about with synchronous replication, in that the primary cannot move forward, cannot process data, cannot allow your application to work if there are pending commits on the slaves. Okay? The synchronous standbys will be those whose names appear in this list and that are both currently connected and streaming data in real time, as shown by a state of streaming in the PGStat replication view. We talk about that a little later. Specifying more than 1 synchronous standby can allow for very high availability and a protection against data loss. I don't agree with half that statement. It is absolutely a protection against data loss. But the fact that a non-moving secondary can cause an outage of the primary makes it so it's not more highly available. The name of the standby server for this purpose is the application name setting of the standby. You set that in the recovery.conf. We'll get to that later. As set in the standby's connection information. In case of a physical replication standby, this should be set in the primary con info setting in the recovery.conf. The default is wall receiver and should be changed. That's absolutely true, because what will happen is that if you just use the default across all your replicas, when you look at your stats, the statistics for your replication, they will all be identified as wall receiver. And you won't necessarily be able to tell which one's which. Lost my train of thought. Yes, okay. All right, so if we look at this a little bit, if we look at, it's kind of hard to see from the back probably. We got our first numseq standby. That's where you're starting to get into the quorum type commit. I don't know of any, I'm not saying they don't exist. Don't get me wrong. I'm not saying they don't exist. But of all of my clients, not a single one of them uses synchronous replication. Every single one of them that has thought they needed it ran it for about a week and turned it off. Every single one. Now, don't get me wrong. If you're doing stock trades, financial data, streaming data of critical nature, it makes sense. But as far as I can tell, in my experience, it's about a 1% proposition. Of all the installations of Postgres in the world, of which there are literally millions, 1% actually need synchronous replication. In fact, I would argue that synchronous replication exists within Postgres not to solve any technical problem, but to solve a marketing one. Because if we don't have synchronous replication, somehow we're not as reliable or enterprise grade or able to compete with evil Oracle or something like that. So if we look at this, the setting here, it says where numSync is the number of synchronous standbys that transactions need to wait for replies from, and standby name is the name of a standby server. First in any, specify the method to choose synchronous standbys from the listed servers. The keyword first, coupled with numSync, specifies a priority-based synchronous replication and makes transaction commits wait until their wall records are replicated to numSync being a variable number of synchronous standbys chosen based on their priorities. For example, a setting of first 3 S1, 2, 3, 4 will cause each commit to wait for replies from the 3 higher priority standbys chosen from the standby servers S1, S2, S3, S4. So I'm going to highlight this. So when we look at that, what we're saying is that we must have committed 3 on the first 3, 1, 2, 3, before we can move forward of the 4 synchronous standbys. The standbys whose names appear earlier in the list are given higher priority and will be considered as synchronous. Other standby servers appearing later in the list represent potential synchronous standbys. If any of the current synchronous standbys disconnects for whatever reason, and this is actually pretty cool. If any of the current synchronous standbys disconnect for whatever reason, it will be replaced immediately with the next highest priority. The keyword first is optional. So in practice, what we're saying here is we must commit on 1, 2, or 3 to move forward. 4, it would be nice if we did it. But more importantly, and this is where you do get higher availability in the newer versions, is that let's say S2 disappears. S4 will actually, everything will just move forward to the left, synchronous replication continues, and the outage does not occur that happens with synchronous replication. If any of the current synchronous standbys disconnects for whatever reason, I already talked about that. The keyword any, coupled with numSync, specifies a quorum-based synchronous replication and makes transaction commits wait until their wall records are replicated to at least numSync listed standbys. For example, a setting of any 3 S1, 2, 3, 4 will cause each commit to proceed as soon as at least 3 standbys of S1, 2, 3, or 4 reply. This is pretty much how Aurora works, Amazon Aurora. They actually do their storage across multiple volumes, and then they have a quorum of what they accept for the database to move forward. First, and any are case insensitive. If these keywords are used as the name of a standby server, its standby name must be double quoted. The third syntax was used before Postgres version 9.6 and is still supported. It is the same as the first syntax with first and numSync equal to 1. For example, first one, S1, S2, and S1, S2 have the same meaning. Either S1 or S2 is chosen as synchronous standby. The special entry star matches any standby name. All right, next we need to edit the pghpa.conf. This is a pretty simple file as long as you don't try to use external authentication mechanisms. The pghpa.conf is the Postgres host-based authentication file. You will need to configure this file to allow for your secondary or replicas to connect to the primary to receive the replication stream. The file looks like this. As you can see, we have local all Postgres using peer level authentication, peer being in order to connect the database that you're connecting to must be named the same as the user that is connecting. It's fine for local stuff, don't use it for anything else. Local all, peer, host all, local host, MD5. Now, in 9.6, MD5 was relevant. In 10, you really shouldn't be using MD5. You should be using SASL. And I think they, with SHA, I think it's 256. But for the case of making this easy, we're going to stick with MD5. We also have an IPv6 local connection. Anybody in here actually using IPv6? Anybody? What was that? Oh, you're using it? Okay. Well, that's good. I mean, so I like the theory of IPv6. I certainly don't like how it addresses. I wish they just used just like Class C type stuff to make it easier to read. Okay, but the bottom lines are what we're really concerned with. Allow replication connections from localhost by a user with the replication privilege. That's the local there. And then the second line, host replication all, localhost MD5, and then obviously it's the localhost for MD5, or sorry, for IPv6. What we need to do is open this up to the world, or at least our internal network, so that we can connect. Particular line we need to change, we need to modify is one of the last three where we are allowing replication. In this example, we want to change the replication lines to something like the following. Local replication all, peer, and then host SSL, replication all. We're allowing 192.168.1.5 to connect over MD5. Notice I changed that to host SSL. I think even internally, even if you have a closed network, you should be using SSL. There's a number of reasons. On Ubuntu, you don't get the compression advantage. I don't know if you do on CentOS. Does anybody know, actually? Does CentOS, did they re-enable SSL compression? No? Okay, well, at least on Ubuntu in the current versions, it does not. And it has to do with a security hole. But more importantly, if you look at studies of industrial espionage, it's something like over 70% happens internally, not externally. So you should protect your streams at all time, encrypt everything. Once you've edited the file, and if you were in the previous class, you'll know this, you can reload the settings with the PGConf reload function as a super user, just from PSQL or whatever other query tool you've got. Just say select PG reload conf. It'll return true or false. If it returns false, there's a problem. Go look at it. If it returns true, you're good to go. Your secondary configuration. The following parameters need modification for a secondary to be brought online. Hot standby. Will the secondary be a hot standby? I don't see why you wouldn't have it be a hot standby. I mean, it's read-only queries anyway, so you might as well just have a hot standby. It makes it more useful. Enabling a secondary for hot standby allows a replica to execute queries in a read-only manner. This can be particularly useful for load balancing or reporting. It is possible to load balance between primaries and secondaries that are on a hot standby, keep in mind that unless it's logical replication, your hot standbys will only be read only. You will not be able to do anything but reporting in just select queries. There's a couple tools out there that allow you to do that. You got PG Pool, you've got Heimdall Data, you've got, I think there's one called SQL Proxy or something like that. And it's also easy enough, if you know what your hot standbys are, you can just have a different connection class for whatever application you're running, so that if you know that the application is, or the query being run is only going to do reads, or you just use that connection class instead of your read-write connection class. Max standby archive delay. Configure this setting when you are not using streaming replication to a hot standby, but instead are using archiving. In short, the secondary will wait this long before canceling a query on the standby. You can set this to -1, which will cause queries to run indefinitely. However, that is not a practical setting, as it will cause bloat on the primary, as the primary keeps all changes that are unable to be applied because there's an open transaction. Does anybody here understand the problem with long-running transactions yeah? Okay, so Postgres, and it's better at it now, but it still has a very significant limitation. If you, sir, log into Postgres on a Friday at 3 p.m. and you say begin semicolon, and then you get distracted by cat videos on the internet, and then you go home, routine maintenance will not work all weekend. You will bloat out your database because you have a long-running idle transaction. This is a very similar problem with hot standbys, in that you've got queries running. Each query is a transaction. So if you have a long-running report, so a report takes 4 hours, the primary is keeping track of all changes that it must ship to the standby that it can't while that transaction is running, which means that the things that aren't being processed are very similar in that it can't do cleanup. The primary can't do cleanup and ship logs to be applied for cleanup because the transaction may still need the rows that are visible to its snapshot. Does that make sense? Okay. Max standby streaming delay. This is effectively the same setting as max standby archive delay, except it applies only to streaming replicas. I should make that distinction. So archive delay is if you are using archive mode on and archive command to ship your replication information. Whereas max standby streaming delay is the invert, not the inverse, but the reverse, where you are using streaming replication, which means the secondary is connecting to the primary to receive its replication information. Okay? Just as a side note, I know you all weren't in here, but you completely cleaned us out of our mammoth stickers, which is kind of cool. I'm glad you guys did that. A note about the delay settings. The setting is not the same as the maximum length of time a query can run before cancellation. Rather, it is the maximum total time allowed to apply wall data once it has been received from the primary server. Thus, if one query has resulted in significant delay, subsequent conflicting queries will have much less grace time until the standby server has caught up again. So we're not talking about disconnecting replication or killing a query. What we're talking about is we had a long-running query that had all this information backed up. We've now, the query's finished. We've shipped or streamed all the new information. Other queries might get canceled because that information hasn't yet been applied. Wall receiver status interval. Tell the standby how often to update its master on the current status. If set too high, PGStat replication will be out of date, and you may overrun replication timeout on the master. So wall receiver status interval says, hey, standby, I'm a standby, I'm going to let the primary know my status every X seconds or milliseconds. And if I set it too high, PGStat replication, which tells me how far behind my standbys are, won't necessarily be accurate because it hasn't received an update from the interval, or an interval from the update. If I said that right. Hot standby feedback allows the standby, including cascading standbys, to tell the master what queries are being run so that the master doesn't remove rows during cleanup and cause a query cancellation. This can cause bloat. Okay, so this says, I'm a hot standby, I got all kinds of things being run, I need to make sure that the new information coming across from the master doesn't remove the rows from the snapshot that I'm currently working in. However, because of that, depending on what's going on, it can cause bloat because the primary is holding on to all that information, waiting to ship it across. And since we have MVCC, we end up in a situation where we have many versions of the same data because it had been modified, changed, nothing's been committed, that type of thing. Wall receiver timeout. The amount of time to wait for replication connections that are inactive before disconnection. I think that's pretty obvious. If not, please let me know. But I think that's probably the simplest of all of these except for hot standby on. Wall retrieve retry interval. Specify how long the standby server should wait when wall data is not available from any sources, streaming replication, local, PGX log, or wall archive, before retrying to retrieve the wall data. The interval is not so much interesting as the fact that you can have multiple sources delivering the same information. For a long time, in fact, until replication slots came about, my recommendation, and in my opinion, the best practice for replication, binary replication, was that not only did you stream to the secondary, you also shipped your logs via archive command to the secondary. And the reason you did that is because if your connection dropped, those wall logs could still be applied even if you overrun something like wall keep segments, the old wall keep segments, because you're still shipping those logs all day long, and if you can't ship them, it's like a global replication slot because Postgres says, I can't ship this log, so I'm going to keep it. I can't ship this log, so I'm going to keep it. Then all of a sudden the secondary comes back up, it ships all the logs over, it catches back up because it has the logs, and then can connect to the primary to start streaming again. Okay? Nowadays, that is not quite so important because you have replication slots. And replication slots are machine distinct, basically buckets of archive logs. All right, now that we've done all the talk, not all the talk, but while I'm hydrating, does anybody have any questions? Yes. I know you. I don't know why I know you, but I know you.
Добрый день.
Hold on, I need. Where's the translator thing?
Добрый день. У меня вопрос про настройку PGConf. Вот у вас слайдик был по этому поводу. Я хочу спросить, допустим, у меня есть репликация, несколько реплик. Я хочу, чтобы на одну из них реплика шла через SSL, на все остальные без шифрования. Как мне прописать это в PGConf? То есть что я должна там указывать? Понятно?
Okay, so basically you want to be able to run SSL over one connection, but not over all of them. There's a couple of ways that you can do this. The simplest is, and I talk about it a little later, but the simplest is that you can tell your recovery.conf in the connection info, you can say SSL mode require or SSL mode try or none, and then whatever secondary is connecting, based on the connection string itself, it will determine whether or not it's SSL encrypted. That's one option. The other option is you can actually, in the hba.conf, force it. So you can say, in the hba.conf, you just say host, and then the IP address of each secondary. And if you just use host, it won't require SSL. And then for the host that you want to require SSL, you just say host SSL, and then in the connection info, you connect. Does that make sense? Okay. Any other questions? Yeah.
Можем ли мы использовать логическую репликацию между базами данных, которые немножко отличаются? Например, в базе данных, которая в стендбай, отсутствуют некоторые таблицы или отсутствуют некоторые колонки в таблицах. Это первое. Второе. Можем ли мы воткнуть middleware?
Let me answer one at a time. Let me answer one at a time. Okay, so we will talk about this a little further in logical replication, but yes, you actually can. That's the whole point of logical replication, is that you can do weird stuff like that. You can replicate a single table. You can replicate a group of tables. In terms of the column missing perspective, what has to happen is that you can have, let me see if I can say this correctly. On the subscription, you can have more columns, but you cannot have less. So you can have a situation where a publication will replicate, let's say you have a table on your primary, on your publisher that has 3 columns. And you have the same table on your subscriber and it has 5 columns. As long as the order and the 3 columns match, it will replicate. But you can't do it the other way. So you can't have less, but you can have more. Does that make sense? Okay, what's your second question?
Второй вопрос. Мы можем вставить какой-нибудь middleware между мастером и стендбай при логической репликации так, чтобы мы могли самостоятельно транслировать, преобразовывать эти запросы?
Interesting. You could. What you would do is have a custom, and my business card's right over there, we can help you with that, a custom logical decoder. And what it would do is connect to your publisher and read the stream, and then you could tell it based on the stream, do whatever. For example, it could say, the publisher will say, I am sending publication X. And we could configure that logical decoder to say publication X actually doesn't go to Replica, it goes to Kafka. But publication Y goes to the Replica, which would be the subscription. Yes, you could absolutely do that. That's the glorious thing about logical replication, is that all logical replication is the decoding of the logical stream from the wall going somewhere, wherever it is. Now, in this case, we're only talking about Postgres, but we can absolutely send it anywhere because we can decode it. Any other questions? Can someone grab the mic?
Представим ситуацию. У нас есть мастер, slave, вот, и валы мы хотим накатывать не архивами, а это у нас общий диск. В таком ситуации, то есть такой конфигурации мы можем сделать? Когда валы у нас на одном диске, и его читает и мастер, и slave.
No. I'm going to say that one more time.
Почему?
No. It's a common. It's actually an old. It's if you've been doing this as long as me, it's called the shared disk idea, right? Shared disk high availability is one of the ways it does that. Postgres can't do that. I mean, theoretically, it would be possible, but it wouldn't be reliable because the master is going to control what happens to those wall logs. And then you're going to get conflicts because the secondary is going to think it's in one state, the master is going to think it's in another state, and it might remove one of those wall logs, and then all of a sudden the secondary is dead. It won't work. And you wouldn't really want to do that anyway because it's going to reduce reliability. Now, you could use shared storage for something like point-in-time recovery. Right? You absolutely could do something where you have shared storage for archive logs and you're restoring from multiple sources from a single source. That you could do, but from a replication perspective, no, that's a bad idea.
Из-за того, что slave удалит, да, вал?
Well, either one might. That's the thing, is either one might, and you don't know when or what. So the master might remove it, and the slave doesn't have it. Or the slave might, if the slave removes it, as long as the master's already used it, the master's not going to care. But either way, what you're doing is you're creating a double dependency from a single source, and it's not going to work. Next, I think right behind you.
If we use binary replication, we can run read-only query on slave. But if query is heavy and run for a long time, it stops replication into slave. Can we use some, or is there exist any version mechanism that can save copy of page into some location in order to provide them for this long query?
So, no, not really. I mean, the way you would do it...
not to stop and blocking, but same as Postgres version mechanism.
Right.
Likely.
So I think what you're asking me is what we were just talking about with how a hot standby with a long-running query, it will basically, it doesn't stop replication, but it effectively stops it, where the standby is not receiving updates because of an open snapshot. There's no real good way to deal with that without, you got to set your settings low enough to where the long-running query won't be an issue. What I find is most useful is to have multiple replicas, one where it is OLTP only, right? So you have your primary and your secondary, and they're both OLTP only, which means the queries are always going to be as fast as they are going on the primary. And then you have another replica, which is going to be your reporting server. Mm-hmm. And that one, you just got to accept sometimes might be behind.
Thank you.
You're welcome. All right, anything else before we continue? Yes.
Okay, thanks for the half part of great talks. And you told about the situation when we have one master or one slave for this primary base and two slaves, 2 and 3 for first slave. And as I remember, Postgres can dynamically redirect 3 or 4 slaves to the master if we lost second slave, yes?
Yeah, it's called timelines.
Yes, and that's why I have a question. If we give 1 slot for our slave and we lost him, we have, for example, 3 slaves which retrieve data from first slave, and now he tried to get this archive from master.
Say that last part one more time.
Okay, we have master and 1 slave for this master, and a few slaves for first slave.
So you have a master, and then you have a slave, and then you have a couple of slaves that are connected
yes, schema on second page.
So the cascading.
Yes, and
okay.
we lost first slave.
Okay.
Can Postgres dynamically force to other slaves takes data from master?
Okay. So I'm going to say back what you said for
yes.
everybody. As I understand what he's saying, or asking, if you take, let me check what page I'm on here so that I don't miss this. 15. Okay. So if we go all the way back up to the binary replicate. Here we go. This guy here. So what he's asking, we have our master and our slave, and then we have slave 2 and 3. What happens when slave 1, let's just, for whatever reason, it dies? Can we make slave 2 and 3 reconnect to the master and just proceed? Is that correct?
Yes.
Okay. The answer is yes. I can't tell you exactly how it's done. I know that there are some issues in that. One, you need to make sure that you have the logs because likely slave 0 has already consumed those logs, and slave 3 and 4, that is 3 and 4, or 2 and 3, will need those logs in order to connect to the master and be up to date. So you would either have to be archiving, where the slaves would know, okay, I can't connect and now I can connect, and restore those in like a point-in-time recovery situation, or you would have to have a scenario where you have a couple of replication slots that are doing nothing until they connect. And secondly, there's another part of this that has to do with timelines. That's the part I'm not real clear on. But yes, it is possible. I just don't know exactly how to do it.
Okay, thanks.
Okay, anything else before we proceed? Oh, there's another one.
So, if master will down because of internet connection or something, can the replica dynamically upgrade to master?
Yeah, absolutely. And we talk about that a little bit. Basically, in your recovery.conf, or not your recovery.conf, there's one, you can do it through your monitoring software, of course. But there's a command, it's PGCTL promote. It's literally that simple. And it will promote whatever hot standby or slave to a master. And then there's also another opportunity. It's called a trigger file. And that basically you tell the recovery.conf, if this file exists, promote. And so you can have a situation where your monitoring software, for example, you detect that the master is down, you double detect that the master is down. So you know for a fact that machine is down, it's not coming back. And then you literally just touch, the command touch, the trigger file. Postgres will detect that the trigger file was created and promote itself to a master.
Thank you.
You're welcome. All right, so we're actually at break time here. I can take one more question before break, but then we'll break for coffee or afternoon, whatever they do here. Anything else? All right, see you in a half an hour. Thank you.